This is a rectangle. The properties of a rectangle are very simple. Opposite sides are equal, and the four right angles are equal. Geometry, normally called Euclidean geometry, should really be called rectangular geometry because it's really the geometry of the rectangle. The parallel lines, the lines of the rectangle, are the lines that you can produce a rectangle with. So lines that are parallel are lines in which you can construct a rectangle. Now, we can get some of the properties here by doing something simple like this. We'll just slash a line through here. Now, with this line slashed through, because these are parallel lines, we can construct another rectangle. So we'll do that here. Now, because this is a rectangle, this and this side are equal, and this side and this side are equal. That's equal to itself, so the two triangles, this one and this one, are equal. And what that means is that this angle here equals this angle here. This is called alternate interior angles. Now I'm going to go one more step here. Draw a triangle. And now we know this angle equals this angle. So this angle plus this angle plus this angle are a straight line, or 180 degrees. So the sum of the angles equals 180 degrees. Now we're going to go to the next step here, which is we're going to create a parallelogram. Okay, so this angle equals this angle, and because we did it with the angles, this angle equals this angle. It's this angle equals this angle. These angles are equal. So this triangle and this triangle are equal. Okay? And we can do this in several different ways, but that's true. So the area here that's subtracted from the rectangle is added over here to the parallelogram. So the area of the parallelogram and the rectangle are the same. Now I'm going to take one more step here. I'm going to draw a diagonal of the parallelogram. Right? This side equals this side. This angle equals this. All the angles are equal. So this triangle equals this triangle. The area of a triangle equals 1/2 the base times the height being the rectangle that you would create. All right, Now we're going to go one more step. Now that we know that this triangle is 1/2 the base times the height, we can go to one more step. Here we have a right triangle. This right here is the right triangle, and it has a square built on each of its sides. This is the longest side, called the hypotenuse. Call this side A. Call this side B, just for fun. Call that H for the hypotenuse. Sorry, that's the name they decided to give it back when they were Greeks. So now what we'll do, you'll notice there are right angles here, 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 and here. So what we're going to do now is we're going to construct, we're going to draw a line from right here straight down. It cuts this into two rectangles. And then I'm going to show that this rectangle equals this square, and this rectangle equals this square, so that a squared plus b squared equals h squared. So to do this, we're going to draw a couple more lines. This line right here and this line right here. Now, this angle right here is the sum of this right angle plus this angle, and this angle right here is the sum of this right angle plus this angle. This side equals this side because it's a square. This side equals this side because it's a square. So this triangle equals this triangle. Now we know that this triangle is 1/2 the base times the height of the rectangle. So here's the rectangle for this triangle, and here's the rectangle for this triangle. So this equals this. I can draw, I guess I'll just draw the other lines for the other one, which do the exact same thing. I'll get rid of these. Okay. The other rectangle, of course, is this one right here, and we can draw from right here to right there, and we can draw from right here to right there, and we get the same thing. This triangle here is half this rectangle. This triangle here, which is the same as that one, is half this square. There you go. couple more things about rectangles. So here we have a rectangle made up of some aluminum bars. And you can see that this rectangle is very easily deformed. Which makes the rectangle an unstable structure for buildings, even though most of our buildings are made with rectangles. So to solve that, we need to add another bar. If we add another bar, like this, our rectangle becomes extremely rigid. Now any sideways pressure will not move the rectangle. Another thing to think about is force placed along this line here can be resolved, that is, converted into a force in the vertical direction and a force in the horizontal. And this is used a tremendous amount of the time in all sorts of applications. We call the analysis of these forces vector analysis, where we take a force, resolve it into two. A velocity. The velocity, say, if this is your latitude, and this is your longitude, and this is your course, the velocity along the latitude is this. The velocity along the longitude is this. We can use the Pythagorean theorem to resolve all of this if all of the angles are right, as in the case of, say, latitude and longitude, or horizontal and vertical. And that's certainly enough for most applications we'd be at all interested in. Another way of looking at it is how much, if we have a downward pressure on here, how much side thrust do we get? Well, if we look at the downward pressure on this, that would be pressing this out. The side thrust would be this. The pressure there would be the horizontal, or the vertical pressure would be that. If we had another roof this way, or another truss structure, the downward pressure is this, the side thrust is much less.